If a man starts at a point 1 kilometers west of his home, and he ends up 3 kilometers west of his home, and he does this in 60 minutes, how fast did he walk? And what was his velocity? So I'm going to answer this question. We have his home, which is drawn by this nice little house, and he starts at 1 kilometers west of that. So on our compass, we have our north, south, east, and west directions. He is 1 kilometer west, so to the left. And we call this x1, his starting point, and it's at 1 kilometer. Then he ends up 3 kilometers to the west, so he's walking further west away from his home and ends up at 3 kilometers from his house. So x2 equals 3 kilometers. Then he does so in 60 minutes, so he starts at this point when the clock is at 0, and he arrives 60 minutes later. So he's walking this way. Okay, so what's his velocity? What's his speed? The velocity, average velocity that is equal to delta x over delta t. So that's our central equation. Now this is the difference in displacement, or difference in position, divided by the difference in time. And we can see we can just plug our numbers in here. So this is equal to 3 kilometers minus 1 kilometer over 60 minutes minus 0 minutes. And what we get is that his average velocity is 0.033 kilometers per minute. So we have kilometers. This will be 2 kilometer displacement. So our displacement is 2 kilometers. Well, our distance is 2 kilometers. Our displacement would have the west direction to it. But 2 kilometers, and then 60 minutes gives us this answer. Now this answer is in kind of ugly units, so I'm going to convert it to something better, such as meters per second. So let me do that. And I did a video on how to convert units a while ago. It's in the Introduction to Physics playlist, but I'll do it here step by step. So 0.033 kilometers per minute. So we want to convert minutes to seconds. I'm going to convert this to meters per second. So minutes is in the denominator, so we want to cancel that out and put it in the numerator. And so we say that 1 minute contains 60 seconds. So that's now converted to seconds. Now we also want to convert kilometers into meters. So kilometers is in the numerator, so we put it in the denominator here. And we say there are 1,000 meters in a kilometer. This gives us V average of 0.033 times 1,000 divided by 60, which works out to 0.55 meters per second. Now, the question asks, first, how fast did he walk? And second, what was his velocity? And this is kind of tricky, because how fast he walked, this is speed. Speed is a scalar. Velocity is a vector. So these are two different things. What we just calculated here is the speed. Because there's no direction, we just plugged the numbers in and we calculated the raw numbers independent of direction. But now let's find the velocity. And this question is simple because it gives us the direction. He walked west. So the velocity would simply just be 0.55 meters per second west. And it's that simple. Sometimes it's not always that simple, but this one, it just explicitly tells us what the direction is. Now, if you wanted to use unit vector notation, we could take, as usual, if we have our diagram, the right could be positive x. This could be the I hat direction, in which case our answer would become negative 0.55 because we're going this way, opposite to positive x. And then we'd have our unit, and then we'd put our I hat unit vector to show that this is a vector on a two-dimensional plane, although it's only along one axis, so it's one-dimensional, along the negative x direction with a magnitude of 0.55. And so either of these two answers are fine. And that's how you do this problem. So thank you for watching.